Okay, so here's the warm-up, and you guys can get started on the warm-up. Yeah. How's everyone's day today? Nice, okay. Just fine. Okay, sure. Um, Edward, do you have a question? Okay, okay. Just making sure. Yes. Oh, no problem, Ian. No problem. Give you guys a few more minutes. These questions shouldn't be too bad. Pick some easy ones for you so we can get straight to the lesson today. Okay, time's up. Does anyone need more time? Or you want me to move on and share how you can guys do the questions? No? Okay. Well, I guess I'll just, move on. Okay, does anyone have any questions? Did anyone struggle with anything here? It was all fairly simple. Anyone? No? Anyone else? Oh, other than Bowen. Anyone other than Bowen? You can say yes or no. Okay, cool, cool. So here, let me just give you guys the answers and you guys can compare and see if you guys got the same thing. For the first one, it's 149.6. Second one was 1.68. Third one was 4.6. And fifth one was 10. Okay? And so cool. Did anyone get anything wrong and need to ask me any questions or can I just move on? Yes? Okay, cool. Seems like you guys got that, so let me just move on then. Okay, do that. So, okay. And then today we'll be having a quiz on yesterday's topic. It'll be about the basically decimals, adding, subtracting, and multiplying and dividing decimals and things like that. Yep. And you guys can do the link, and then once you guys are done, you can tell me, and then I can move on. What do you mean same as last time? Again, once you guys are done, you can put in chat, you say you're done, and then I can move on. Cool? Okay. Okay, seems like one person's done. Anyone else? Okay, cool. Does anyone need more time, or should I just move on? Okay, so it seems like everyone's done, so let me move on then. So today we'll be learning about exponents, and um, to get you guys like getting to know exponents a little better, I ran a short video on how you can fold paper many times and how folding paper can be represented as an exponential function. It's pretty cool. Oh, okay. Well, this is just a video, so it shouldn't be too bad. You guys can watch or finish the quiz. So yeah, let me share my sound. Okay. That's weird. Okay. Give me a second. That doesn't seem like the sound shared. Figure this out for a second. Hmm. Oh, it's good? Okay. That's weird. That's weird. Okay. Hmm. Yeah, I was in.
How many times can you fold a piece of paper?
Can you guys see this?
Assume
Can you
that
see
one
this?
had a piece of paper that was very fine, like the kind they typically
Yeah.
use to
Okay.
print
Cool.
the Bible. In reality, it seems like a piece of silk. To clarify these ideas, let's say you have a paper that's 1,000th of a centimeter in thickness. That is 10 to the power of minus 3 centimeters, which equals 0.001 centimeters. Let's also assume that you have a big piece of paper, like a page out of the newspaper. Now, we begin to fold it in half. How many times do you think it could be folded like that? And another question. If you could fold the paper over and over as many times as you wish, say 30 times, what would you imagine the thickness of the paper would be then? Before you move on, I encourage you to
Yeah.
actually think about a possible answer to this question. Okay, after we have folded the paper once, it is now 2,000ths of a centimeter in thickness. If we fold it in half once again, the paper would become 4,000ths of a centimeter. With every fold we make, the paper doubles in thickness. And if we continue to fold it again and again, always in half, we would confront the following situation after 10 folds. 2 to the power of 10, meaning that you multiply 2 by itself 10 times, is 1,024 thousandths of a centimeter, which is a little bit over 1 centimeter. Assume we continue folding the paper in half. What would happen then? If we fold it 17 times, we'll get a thickness of 2 to the power of 17, which is 131 centimeters, and that equals just over 4 feet. If we were able to fold it 25 times, then we would get 2 to the power 25, which is 33,554 centimeters, just over 1,100 feet. That would make it almost as tall as the Empire State Building. It's worthwhile to stop here and reflect for a moment. Folding a paper in half, even a paper as fine as that of the Bible,
Yep, it's pretty big.
25 times would
No,
give
I
us a
don't think
paper
that the
almost
paper
a
would
quarter of a
fold that
mile.
many times, though.
What do we learn? This type of growth is called exponential growth.
Yep.
And as you
And
see,
then
just
the
by
graph that you're
folding a
seeing
paper,
right now,
we can go
this is
very
an
far,
exponential graph, and
but
you guys
very
will be
fast
learning
too.
that later on in this course.
Summarizing,
And
if
it
you
basically
fold a
shows
paper
how
25 times,
there's a x
the
and y
thickness
function,
is almost a quarter of a
and
mile.
the further down you go down the graph,
30 times,
the bigger and bigger
the thickness
the
reaches
paper gets,
6.5 miles, which is
larger
about
and
the
larger
average height that
the
planes fly.
folds become,
40
and
times.
the higher
The thickness is nearly
paper goes.
7,000 miles, or the average GPS satellite's orbit. 48 times. The thickness is way over 1 million miles. Now, if you think that the distance between the Earth and the Moon is less than 250,000 miles, then, starting with a piece of Bible paper and folding it 45 times, we get to the Moon. And if we double it one more time, we get back to Earth.
Okay, cool. Okay, does that make sense, everyone? Oh, share. Okay. Yep, cool. Yeah, that was kind of fun. Kind of shows you how even with exponents, you guys can use like everyday things like paper and really represent how you guys can double things easily. So for today, we'll be reviewing positive exponents and then also be delving into, yes, the paper will get too large for you to fold. Yes. So, I mean, what they're saying is that, yes, theoretically you could do that, but no, the paper would tear. Okay, yep. So, yeah, today we're going to be going over not just positive exponents, but also negative and square roots today. So, let's first go over positive exponents, and you guys have already learned about this in the PINDOS course I did. So this is just a review. Again, exponents is an operation that multiplies the number by itself for the amount that's listed. So for example, 2 to the power 5 is 2 multiplied by itself 5 times, or 32. And then again, you can use a small number next to this, a small number next to the big number to indicate exponents, or you can use a caret symbol right here, which is the same as a small exponent sign right there. Okay, and then just for you guys to know, an exponent of 0 is always 1. So no matter what number you put to the 0 power, it's always 1. Cool? Does that make sense?
Yeah, it makes sense.
Yes? No? No? Clear.
Yeah.
Not really. What doesn't make sense? The exponents to the 0 power? Yeah, okay. So think about what is exponents to 1 power? What's that? That is 7 to itself, right? Yep. But what do you mean by, well, why is it 1, 0? Could you unmute and explain?
I'm confused. Like, why is it like it's like 1 times 0 times? Isn't it just like 0? I think it's like, why is it 1?
Oh, okay. Give me a second. That's weird. I can't hear you right now. Let me stop doing this, and then let me check my sound settings. Sorry about this. I can't hear you guys for some reason. Okay. Can someone say something?
Can you hear me?
Okay, I still can't hear you guys. That's weird. I can't hear you guys at all. Huh. Okay. Well, seems like I can't hear you guys, but you guys can hear me, right? No, I
Yeah,
did
I
turn
can
off
hear you.
sound share. It's still not working for some reason. Well, I just want to keep decreasing. How to keep dividing? Yeah. Yeah. Base mode itself result in 1 except for 0. Yes, because 0 divided by 0 is undefined. You can't divide 0 by 0. Yeah, okay. Yeah, thanks, Eric. Cool. Does that make sense? Resume
Yeah.
share. And let me clear this. Cool. Okay. So let's just do some practice. It's very simple, just 5 questions. It shouldn't take you guys so long. Oh yeah, I realized I got kind of carried away with the last question. So yeah, let me make it simple. Let's do just 5 to the 5th power. Hmm. Okay, seems like everyone's done, and let me just go over this very quickly. So, actually, Andrew brought up a really good method to solving exponents in long strings of these, basically. So, let me show you what Andrew did. What he did is that he grouped these strings into small, easy numbers, and afterwards, through the associate property that we learned in the first class, we get 81 times 3. And for the first question, we get 243. So through associate property, we can easily solve 2 to the 5th power without having to go through so much trouble. Okay. So let me go on to the next So for the next question, we have yeah, right, Bowen. It's kind of confusing, but as long as you count back how many threes you add up, you should be fine. Yes, Ian. The that's the answer to 5 to the 10. And I don't expect anyone to do that because it's a bit much. And usually at that point, they would just give you a calculator because 5 to 10 is too large of a number. Yes, you can use it with, you can do it without calculator, but it's a lot of unnecessary work in my opinion. Yeah, Andrew, you could, but I would still go with 49 times 7 because you can still mess up sometimes if you don't do it correctly. Yep. Seems most of you guys got this. So then 7 to the power of 3 is just 7 times 7 times 7, and that is 343. Shouldn't be too hard. This is 49 times 7. And then when you solve this out, it's 343. And then 9 to the power of 0, again, this is just 1. Just remember, anything to the power of 0, even like 100 to the power of 0, is just 1. Because it's kind of dividing by itself. Cool? Okay. Then let's do the last one. Yes. 4 is 0. Okay. And then if you have a 9 to the power of 1, it's just 9. Because basically anything to the power of 1, its own identity, basically. Yeah. What I was gonna say is that you could have also grouped them into groups of 3. So you know that 5 to the power of 3 would be like 125, and then you can do that 3 times. You want to do 5 to the power of 10, Ian. But in this case, I simplified to just 5 to the power of 5. So I'm gonna do just, instead of doing 5 times 5 times 5 times 5, or 5 multiplied by itself 5 times, I simplified it down to just 25 and 125. And then once you solve this out, doing two numbers, 5, 2, 2, 1, 6, 0, 1, 5, 2, you get 5, 2, 1, 3. So 3,125. Yeah, you can also group the fourths, but I think that's sometimes a little too big. And then, well, sometimes I think it's too big. Once you get into like the thousands range, it's a little hard to group them into groups of 4. I usually want to do like groups of 2 or 3, so it makes my job a bit easier. Okay, cool. Let's move on. And here, I have a word problem, and I'm going to try something new today, and I'm going to try, let's see, I'm going to try some breakout rooms. So I want everyone to write this question on a piece of paper, and then I want you guys to work it out as a group. And as a group, I want you guys to answer what you think is the answer. Cool? So this word problem is just about exponents, and it shouldn't be too bad. Okay. Okay. Has everyone finished writing down this question? Okay. Cool. Then once you guys are ready, I'll assign you to breakout rooms, and you guys can start and try and solve the word problem. Cool? Okay. Check this. Okay. Again, if you guys have any questions, you guys can ask me. Oh, Quinn, do you have any questions? Okay, seems like everyone's back. Here, let me ask, um, group one. What was, okay, I was in group one. Okay, let's start with group two. I helped group one. Group two, what is your answer? Anyone from group two can answer.
We didn't even do anything.
Okay, well, here. Seems I forgot the groups. Well, you know what? Let me just answer this since this was a hard question, and let's see if any of the groups got this right. So if a ball would double its size every minute and it start off with a diameter of 3 inches, how big would the ball be in a whole day? So let's think about, first of all, how many minutes are in a whole day? Can anyone tell me that? Yes, 144. So there's 1,440 minutes in one whole day. Now, if say I was to double something, what number would I use to double it with? Close, close, not 3, not 3. Yes, 2, yes. So I would use 2 to double it. And then finally, after I get my doubling equation from doing 2 to the amount of times it'll double, I then start with its original principle, which was 3 inches. So in the end, the correct answer would be 3 times 2 to the 1,440. And you can leave your answer just like that, and that'll be the correct answer. Yes, 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 Ian, yeah. Yep. Yeah, Andrew, that answer is correct. Yep. So all you do is that you just double 2 many times because the ball is doubling in size. Yeah, times 2, it doubles in size. So remember, exponents, it goes bigger and bigger. So like remember when you see a small ball, it doubles in size, doubles in size, and doubles in size, it gets super big. So this is how I can represent like an exponential function. So this is a pretty cool question. And it seems like some of you guys got this, which is really cool. Okay, let's move on. I think this question took a fair amount of time, so let's pick up the pace. So now I'm going to go over square roots. Yeah, have you guys heard of square roots before? Have you guys learned square roots before?
I know square roots. I also know radical.
Yeah, okay. This shouldn't be too hard then. You don't have any questions over it. Has anyone not seen square roots before? Again, I can't hear you guys. Oh, you haven't. Okay. So let me just quickly explain it. Square roots is the opposite of exponent of 2. So think about 2 to the basically 2 to the power 2 is 4. This exponent is basically you take it back, so it just becomes 2. So think about like having exponent and 2 here, you cancel the 2 and the exponent, the square root out, and you just get 2. Is your sound level up? Yes, I checked my sound level. It's up. It's up all the way. Okay, so Yunki, does that make sense? Sorry if I butchered your name. Yeah, okay. So square roots is just dividing squares, and squares is just 2 to the power of something. Well, not 2 to the power of, well, squares is just like 7 to the power of 2, 8 to the power of 2, anything to the power of 2 is a square. Well, let me clear the drawings and, okay, cool. So I think I'll give you guys about, I think 1 minute, shouldn't be too bad. These are all perfect squares, so it should divide evenly or resolve evenly. Wow, okay. Some people are really fast. Yep, Queen, that's right. Yep, it's just 6. Okay. See you guys got this. Let me just go over them. Okay, so for the first one, whoa. Okay, yeah, you're right. That was weird. So for the first one, again, this is a perfect square of 6. So when we do a square root of 36, we can cancel this out, and we get just 6. Again, for the 4, 4 is 2 squared, and then when we square root both, we get just 2. 9. 9 is a perfect square of 3, so it's just 3 squared. We cancel these out, it becomes 3. I don't know, Ian, but I'll get back to you. Maybe. Okay, so let's do 4, 81. Again, it's just 9 squared, so when you cancel these square out, it becomes 9. And then again, 144 is just 12. Cool. Okay, let's move on. Oh, so then here's the tricky part. What happens if the number inside the square root is not a perfect square and it does not simplify evenly? So what happens now is that you have to plot the factor tree. I believe everyone here has learned the factor tree, right? I taught this in a previous week. I believe week 2, the factor tree. So in this case, if the number inside is not a perfect square, we have to use the factor tree to try and simplify the square root as much as possible. So say we have 20 here. So if we draw the factor tree, we have 20, 5, 4. Yeah, you're trying to reduce it to its prime factors. So 2, 2, and 5. Yep. So now we know that there's 2 2s and 1 5 that makes up 20. So since, yes. So Andrew, you're right. Since 2 is repeated, that means that 2 is doubled and that there is a perfect square inside it. So we can move basically this perfect square out of the square root and just have 2, 2, 5. Yep, that's it. Yep. Yeah, it's sort of like a radical, sort of. Cool. Okay. Does that make sense, everyone? Yes? Okay. So let me move on. And here's just some practice. This also should not take too long. I made it pretty easy. I left one perfect square in each of these, so you guys can simplify them very quickly. I would check the first question. Yeah, think about what I said. You gotta first draw the factor tree and see which 2 prime factors match, and you take those outside and just have it one of the prime factors represent. So say if there's like a 4, you put 2 on the outside. If there's a 9, put 3 on the outside. Okay. Oh, need to move on a little quickly, so I'll start in another minute. Shouldn't be too bad. Okay? Is everyone done? Let's load the answer for the first question into chat and press enter in 3, 2, 1, go. Okay, can you guys hear me? Yes? Okay. Let me try that again. Yes, okay. We have one answer from Andrew. Okay, Bowen. I don't see your answer yet. Press enter in 3, 2, 1, go. Anyone else? Just Andrew? Does it make sense? Does this make sense? Okay, okay, cool. Anyone else? Okay. Yeah, okay. So let me just work this out again. So let me draw the factor tree of 90. I get 9, 10, and then I can just stop here because I know 9 is a perfect square. And then I can just take the 9 times 10 and the square root and move this out because this is technically 3 to the power of 2 times 10. And I move this out, I get 3 square root 10. Oh, it keeps deleting the message? Okay, that's weird. Okay, cool. Now for the second question, again, factor tree. I know that this is 4 and 30. No, I can stop here because I know this is just 2 times 2. So again, I just move it outside. Oh, okay, yeah. You're fine, Bowen. So this is 2 to the power of 30. Sorry, 2 with times square root 30. And then let's do question 3, 40. We have 4 here, 10 here. And then this is a perfect square. Move the 4 out, becomes a 2. And then now as a square root of 10. So the answer for question 3 is 2 times square root of 10. Question 4, again, pretty simple. We have 4, 7, 4 is a perfect square once again. So 2 to the power of 7, and then 9, 99. 9 is the perfect square, 11 here, and then we have 3 times square root of 11. Okay, does this make sense? It shouldn't be too bad. And every number could have a way to simplify these square roots. So make sure that if you get a big number, you always try out all the ways you can square it out and simplify it, because then you can further solve equation and further simplify equations. And that will get more and more important once you guys understand X and variables like that. Okay, let's move on. Okay, and yeah, we don't have time for this. Let me just skip this. Now let's do negative exponents. This is also very simple. So basically with negative exponents, all you do is that you just flip the numerator and denominator. That's it. So for 3, for a fraction of 3 divided by 5 to the negative 1 power, you just flip the 5 to the top, 3 to the bottom. And then for 2 to the negative power of 3, you flip the 2 to the 3, which will be 8. And then you flip it upside down, which will just be 1/8. So this is technically 8/1. You flip this goes top, this goes bottom, and just change positions. Yeah. Yep, Andrew. That's right. But not everyone understands n yet. So I'll try to explain things in better terms. Cool? Does that make sense? It's not too bad. All you do is you just flip. And if it's a whole number, remember anything divided by 1 works. So you can flip this and this will become 1/8. Okay, let's move on. And then let's do some practice problems. Okay, yeah, no problem, Bowen. I'll just explain these. Again, just remember them as not being negative, and just think of them as just like 5 to the power 2, 7 to the power 1, 10 to the power of 3, 3 to the power of 4. So let's just do the first one right now. So I'm gonna first think this as 4 to the power 2. So Bowen, type in chat what is the answers to 4 to the power 2. Um, no, just 4 to the power 2. This is not square root, this is exponents, remember? Yes, it's 16, yeah, and Key said it right. So it's 16. Now, I see that there's a negative exponent. All I do is I just make it 1 above and then divide by 16. And this is your answer. That's it. Yeah, it's 16. 4 to the power 2 is 16. No. It's not a square root. A square root would have this function. You see this? This is a square root. A small number next to a big number is the exponent. Yes. So square roots are the opposite of exponents, but negative exponents basically just flip the numerator and denominator. That's it. Does that make sense? Sorry. Yeah, it's very simple. All you do is just have 1 on top divided by whatever number you got. Does that make sense, Sunny? Yes, 1/2 again. Actually, I'll be covering that very soon. Okay, Andrew, stop confusing everyone. Just okay. So here, let's load in the answers for question 2. You guys can press enter in 3, 2, 1, go. Hello? Flip that around. Flip that around. Yes, it's 1 divided by 25. Not 25 divided by 1. Oh, okay. Sure, okay. Sunny. Okay, cool. Okay. Yeah, if you guys have any questions, you guys can stay after class. You guys can ask me. So I'm not sure what Sunny's trying to say, but here, let me finish these up very quickly. No, the other Sunny. There's 2 Sunnys. I have no idea what's going on. So again, this is just 5 to the power 2. And add 1 to the top, so it's 1 out of 25. So 7 to 1 is just 7. And then you just add 1 to the bottom. You have 1/7. Yeah. I know. I see that. Yeah. Again, please don't say that. Okay. So here, Andrew, you want to type in chat how you did the question of question 4? Yep, that's it. Since it's just 1, 10 to the power 3 is just 10 times 10 times 10. And then with the negative exponent, all you do is flip it up. And you just flip the denominator with the numerator. And you get 1 over 1,000. Okay. And for the last question, very simple. Again, 3 to the power of 4, 3 times 3 times 3 times 3 is 81. And then do 1 on top. So it's just 1 over 81. Yep. Okay. And yeah, seems like went over a bit over time. So this is it. Yep. And there's the homework. And yeah. Again, if you guys have any questions on today's lesson, or if you guys have, oh, Edward, you have something to say in chat? Again, I can't hear you.
No.
No? Okay. Well, you guys are free to leave now, okay? Yep. I'll see you guys next week. Bye.
Bye. Thank you. See you next time. Bye.
Yep. You too, Eric. Okay. Oh yeah, Ian. Yeah. I think you're right, yeah. If the 2 to the power of 1,440 is correct, then yes. If it ends in 6, that times 3 is 18, so it will end in 8. I wasn't sure that if it was going to end in the 6 though, with a 2 to the power of 1,440. Okay. Well, I'll stop share and I'm it. That's it. So